Okay, we're going to start talking about domain and range today. And as you can see, the first two questions, what is domain and what is range? I've drawn a little line. It's kind of hard to see where all the actual marks are at, but you always read it from left to right and from bottom to top. The domain is all the values of x in the interval, equation, or graph from left to right. So it's all values of x. So we want to think all values of x going from left to right. And sorry about the writing, but it's all values of x going from left to right of the interval, equation, or graph. So you might want to write that down, interval, equation, or graph. And if you look here, you can see the graph starts around the x value here and ends where the x value is here. So it would be about -8 to around +6. Now the range are all the y values. It's all, if I can get it to go, all y values. And we go from low to high. So for the range, we go from here all the way up to here. So from low to high is the range. So you need to remember that. That is something that people tend to miss, is they'll end up going from high to low. But just think for both the domain and the range, you always start at the lowest value of x or the lowest value of y, and you move up to the highest value. So two ways to represent domain and range, and we've kind of gone over these previously. So for interval notation, you have parentheses, so open, or brackets, which means closed. Inequality notation, so that's less than, greater than, all that kind of stuff. So you have less than, greater than, less than or equal to, greater than or equal to, not equal, and equal. Those are all the symbols for interval and inequality. So if we look at our first example, and number 1 here, and you can see with the domain, we go from left to right. So remember, we're going left to right. And as you look at the graph, because it has those two arrows, that means it's moving left to infinity and right to infinity. So our domain would be negative infinity to positive infinity. And remember, when it goes off to infinity, it's always open. Or we could say all reals. And the symbol for all reals is an R with an extra line through it. So it's all real numbers. And then inequality notation, negative infinity is less than x is less than infinity. And then if we were doing our range, we would start at the bottom, and we see because it's going down, it's going to keep going down, and it goes up right to there. So for our range, we start at the bottom, so we know it's going down to negative infinity. So it's open there. But then we can see it goes up and it stops at 4. So it doesn't get any higher than 4, and it's closed at 4 because it stops at that point. It doesn't go any higher. And so we put the bracket. And another way to list it in inequality notation, negative infinity less than y is less than or equal to 4. So don't forget the y. A lot of people will just put x for both. Well, it's wrong if you put x in the range. All right, now let's look at our second example. We have interval notation, inequality notation of the graph over here. And you can see as we're going for the domain from left to right, it goes along there. And so you can easily see we have a point at either end, closed point, so that means we're going to be using brackets. So the domain starts at -4 on the left, and it goes off to +4 on the right, both closed. So in inequality notation we say -4 less than or equal to x less than or equal to +4. When we look at our range, we start low and go up to high. So we can see we start at -1 and it goes all the way up to 5. And they're both close. So then you'd say -1 less than or equal to y less than or equal to 5. So those are our first two examples. Now, if you flip over the page, give me a second here. I need to select my next picture. Okay, we're going to mark it up. Okay, so we look at example 3. And this one, you can see it has lots of different points involved. We do not want to get confused by all these different points. So if we start off with domain, we want to go from left. So the leftmost point is right here. So that is right there on the x-axis. And then the graph moves, 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 and it ends over here at 4, and it's an open circle over here. So as we go from left to right, the domain starts at -4 and it's closed because that is a filled-in circle, and it goes all the way to the right to 4 and it's open. So we say it's -4 to 4. So we'd say -4 less than or equal to x, and then just less than 4 because it's open on that right-hand side. Now if we look at the range, this one gets a little trickier. You have to find where is the lowest point. Well, it's still right here. So the lowest point starts at -4 and it goes up, up, up to here. And so now the highest point isn't at the end point over here. It isn't there. But instead the highest point is right there. So we're going to say the range starts at -4 and it's closed, and it goes all the way up to 1, 2, 3, 4. It's also closed at 4. So we'd say -4 less than or equal to y is less than or equal to 4. So on number 3 there, you have to just look and take a look at where all the different points are and make sure there's no open spots in the middle, and as you can see it works out like this. Now number 4. Number 4, as we look at this graph, I'm going to bring up something that we'll talk about later on down the line, but this graph is approaching on these two dotted lines, and it's never going to cross them. So we're going to assume these are called asymptotes, and we'll talk about those later on, but we're going to assume that the graph does not cross those. And so as we look, when we're talking about domain and range, for domain we're going to go, we see this is an arrow, So we know it goes off to negative infinity and it's always open. And then now we see the other arrow is here and it's going straight down. It's not going to cross over the y-axis. So it's going to go to 0, but because it doesn't actually touch it, it's open at 0. So then we would say negative infinity less than x less than 0. Similarly, so if I erase this and that, if I look at the range, I see down here it's going all the way down to negative infinity. So just like in the domain, it's going off to negative infinity. And then here it's coming up, but it's not going to cross this dotted line. And so because it doesn't cross it, it approaches it, but it never touches it. It gets close to 4, but never touches it. So we would say it ends at 4 and it's open. So the range would be negative infinity less than y less than 4. And we'll go over more asymptotes later on, and I should have drawn the asymptote in earlier, but now you can see. All right, so if we look at 5 and 6, find the range that corresponds to the given domain. And so another way to find range is just plug in the values. So if you know the domain is -1, 0, and 1, we plug in, those are our x values. So we plug those in. So we would say f of -1. So when x equals -1, this is -2 times -1 plus 1, which equals, so -2 times -1 is +2 plus 1 is 3. Then we try the function at 0, f of 0. And we'll talk more about function form as we move along. So f of 0, we do the same thing. -2, we plug in 0 for x, plus 1. So -2 times 0 is 0, plus 1 is 1. And then f at 1, we do the same thing. Plug in 1 for x. So -2 times 1 plus 1 is -2 times 1 is -2 plus 1 is -1. So our range is, and we can just put in brackets, from lowest to highest, -1, 1, and 3. And then close up the brackets, squiggly brackets. We do number 6 the same way. We plug in -2, 4, and 7 into the equation. So we say f of -2 equals 1/2 times -2 minus 3. So 1/2 times -2 is -1, minus 3 gives us -4. When we do f of 4, we get 1/2 times 4 minus 3. So that is 1/2 times 4 is 2, minus 3 gives us -1. And then last one, f of 7. So we have 1/2 times 7 minus 3. And so 1/2 times 7 is 7 over 2, which is 3.5, minus 3, which would give us
Teachers, would you please check your boxes in the teacher room? Please check your boxes before you go to class.
All of our
There are still
answers,
some
so we would
items that
say
will need to be
range
passed out for
is
your advisory period today. Again,
-4,
please check your boxes.
-1, and 1/2, and that's our range. So we plugged in our x values from the domain. Domain is always the x's, the range is the y's, and so we solved and got our answers. And that is domain and range.